Alright guys, so section 6.4 is basically doing what we've been doing but in reverse. You know every time we do something in math we have to go backwards, right? So have your handy dandy table ready and your calculator, and we are going to work backwards. First thing, in thinking backwards, here we go. It says what z value has an area 0.9803 to its left? So all of the areas on here are to the left, right? Correct. So we're going to go to 0.9803 is the area to the left. Oh, there he is. And the z value that goes with that is 2.06. Okay, so you can use the table in reverse. That will be handy for us later. What z value represents the 30th percentile? Do you remember that percentiles were the amount less than that percentile? So we want the area to the left to be 0.30. So this is the area here. So if we go to our table, we want to find the area that is 0.30, and we're just going to get as close as we can. A lot of times it's not exact. So I see there's a 0.2981 and a 0.3015, and the one that is the closest is the 0.3015. So that's at negative 0.52. Negative 0.52. Okay. One more going like this. The z value represents the third quartile. Do you remember the third quartile meant? 75%. So that means it's greater than 75% of the data, and we're looking for the z value here that would give that to us. So we're going to need 0.75, and we're going to get as close as we possibly can. Here we are. We have 0.7486 and 0.7581, so 0.75 would be closest to the 7486. So that's at 0.67. There. Okay. So now that we can use the table in reverse, I've got some words to throw in with it. Nope, not that one. One more time. This one. The area between the z value, so that the area between z and negative z is 0.8. 0.80. So we are looking for what is this z value, so that we would have 0.80. So if it's 0.80 in here, do you remember that this is all symmetric? And so each one of these sides has the same area. So that means that they are both 0.10. Okay? Well, if I know that, then what I know is from here down is an area of 0.90. Now that I know the area is 0.90, I can go look that up on my handy dandy table and get as close as possible. The lighting in here is terrible. Here we go. I got a 0.8997 and a 0.9015. So the closest one is 8997. The winner is 1.28. Okay. So thinking about your symmetry and busting this up into equal pieces. Alright? Let's do one more of those. We want the value of z so that negative z and positive z, the area to the left of negative z and the area to the right of z, these two together are 0.0286. So guess what each one is? That's right, half of that. Okay? Now, if I know that and I want to find this value of z, don't you think I could find this? If I know that this piece here is 0.0143, how could I find the rest of this? Remember the complement? Yeah, there you go. Alright, so let's do 1 minus 0.143. That is 0.9857. This is what we're looking for on here. So 0.9857. Oh, there's one exact. How exciting. That is at 2.19. And that's the z. Okay? So we can find the z's from the areas, and we can find the areas from the z's. Why? Because probabilities and values, they all works together. So I'm gonna do 2 quick little examples. I think we can squish it in here. Jersey cows. The weights of Jersey cows offered at auction in one region are normally distributed. The mean of 825, standard deviation 74.8. One cattleman endeavors to only bid on cows that are in the top 5% of weight. What's the lowest weight cow that the cattleman should bid on? I'll show you what's happening here. He only wants to bid on these cows. He wants these guys. We need to know what this z value is so that we can find out what x value it is. Okay, so we're going to find the z. We need all of this area. So this is 0.95. Go to your table. 0.95. I don't know how well you can see this table on here, but look at yours. 0.9495 and 0.9505 are equally distant from 0.95. So here's what we do. We go smack dab in between the two. So we're going to go halfway between 1.64 and 1.65. So halfway between is 1.645. So the z value there, 1.645. I go halfway between. Now, remember our handy dandy formula, x minus mu over sigma? I know the z. It's 1.645. The x is the weight of the cow I want to find. Mu is 825. Sigma is 74.8. We are solving for x. Don't you love solving for x? I'm going to let you do that. Here's what I got. See if you got the same thing. This is the weight of the cow he is looking for. He wants all of his cows to be at least 948 pounds. Okay? Alright, we're going to do that one more time. Talladega. During one season of racing at the Talladega Superspeedway, the mean speed of the cars racing there was found to be 158.9 miles per hour. Standard deviation 6.7. What speed represents the 30th percentile for speeds of race cars at Talladega? I want you to hit pause, draw a picture, label some things, go find your area, find the z, and then find your x value, which is your speed. Okay? Hit pause and then come back. Alright, I hope that you drew this. We're going to go look up the z-score that goes there, and then the x. So I need 0.3 to be my area. 0.3 is closest to negative 0.52. Okay, so I use my formula, z equals x minus mu over sigma, and I solve for x. Here's where we find out if you got the right answer. I got 155.416. This is the speed of the car. Huzzah. All right, that's 6-4. Go ahead and go to your Google Doc and complete the problems that you need to turn in there. And I would suggest highly that you go and do some of the other problems as well. I would not stop at just doing the couple of problems I asked for, but I would try the odds as well. Okay? All right. See you next time.